Another calculation we can do for a reaction is the percent or percentage yield. Now the equation for the percent yield is the actual yield divided by the theoretical yield times 100. Now the actual yield is what we get from the experiment. So this is done in lab. So if you were doing the experiment in the lab room, this would be how much of your product or what you were interested in that you measured out. So this is what you actually obtain in the lab. A lot of times this, if you're trying to calculate the percent yield, the actual yield has to be given in the problem because we aren't going to run into the lab and do the reaction described in the book. The theoretical yield, this is what we've been calculating. This is from the balanced chemical equation. So far in this chapter, we've been calculating theoretical yields. Because outside of math mistakes or setting up your problem wrong, there aren't reaction mistakes that can happen. So when you look at a balanced reaction, we're not taking into account any of the things that may occur in lab to make our reaction not complete or not as successful. And the things that will make our actual yield less than what we predict could be things that you might have already encountered in lab. Maybe the conditions aren't ideal. Maybe you make a transferring mistake and don't get all of your product from one place to the other. Maybe the reaction ends up not being complete because there's side reactions that occur that the balanced chemical equation doesn't take into account. So there's a variety of reasons why our actual yield is less than our theoretical yield. Really, we should not have an actual yield that's above our theoretical yield. I suppose sometimes in lab, if you have to dry a product, if you don't dry it completely, then your actual yield would end up greater. But in general, we would expect our actual yield to be less than our theoretical yield. So when we're trying to calculate a percentage yield or a percent yield, we have to be able to know what the theoretical yield is. So unless they've given it to us, we have to use the calculations we've been doing in these stoichiometry problems to determine the theoretical yield. So in this problem, it says during an experiment, 125 grams of copper, so I have 125 grams of copper, were placed into a solution containing 275 grams of aluminum nitrate. Then it says 135 grams of silver were recovered. What is the percentage of yield of silver obtained? So percentage yield, we need to know the actual yield divided by the theoretical yield. This sentence right here, see where it says were recovered? This right here is our actual yield. We're not going to use this in our equations to determine our theoretical yield. They're telling me what happened in lab. So you can see this is a limiting reactant problem. We're going to have to go from grams to grams because I was given grams here. And so that means I start with, I'm going to compare my two answers. So I have 125 grams of copper. I have to convert it to moles, and I've included the molar masses here. So I convert it to moles of copper. So remember, I have to convert, if I'm given grams, I have to convert into moles first because the only way I can use the mole ratio is to be in moles. So now I get 1.9669. This is moles of copper. Once I have moles of copper, I can multiply by the mole ratio. Now I'm trying to figure out the percent yield of silver. So let's see, silver has a 2. So that's what I'm looking for, and copper has a 1. So if I multiply by 2 and divide by 1, I get 3.933. I'm not really worried about rounding at this point. So that's how many moles, and I need to figure out the number of grams. And so once I figure out the moles of silver, I can figure out the number of grams by multiplying by the molar mass. And for silver, I wrote the molar masses here. Okay, so I'm going to multiply by 107.9. And I get the three significant figures, 424 grams of silver. Okay, so that's what I would predict from the copper. So now let's write, now I have to compare that because I have two reactants. It's a limiting reactant problem. So they said I had 275 grams of the silver nitrate. So again, I'm given grams, so I'll use divide by the molar mass of silver nitrate in order to change it into moles. So 275 divided by 169.87. I get 1.6188. It's like going to be a 9 moles of silver nitrate. And then I'm going to multiply by the ratio. And again, silver has a 2, so that goes on top. Remember, both cases I'm trying to find out silver so I can compare. Oh, the silver nitrate also has a 2. So that's really, it's a 1-to-1 ratio because they both have 2's. And so I'm going to get 1.61889 moles of silver. Now I can actually look, comparing at these two numbers of silver, I can see that the silver nitrate's limiting because it gives me fewer number of moles. But I need to go all the way to grams anyway because that's what I need for the problem. And I get the three significant figures, 175 grams of silver. So remember what? This is not the percent yield that I've solved for right now. I need to know the percentage yield is the actual yield divided by the theoretical yield. And I was given the actual yield of 135, but I had to figure out the theoretical yield. So a limiting reactant problem, I have to compare these two values, and the one that's the smallest is the theoretical yield. So this number is not part of my answer. I just needed it to compare to see how much I would make. So now I have, let's go, I might have to flip back and forth, but I know my percent yield, which is what this problem wanted, is equal to the actual yield divided by the theoretical yield times 100. So let's go back. My actual yield was given in the problem. It's 135 grams. Then going back, I did a limiting reactant problem to figure out that the amount of silver that I would predict would be 175 grams. And then to make it a percent, I multiply by 100. So finally, I say 135 divided by 175, and then times 100. And I get to three significant figures, 77.1% yield. So that's my answer. And for some reactions, that would be a very good yield. For other reactions, it wouldn't be so good, but that would just be depend.